experiment up here that I want to do with these cans. Now these cans, if you look here, we're talking about air and whether air itself is made out of molecules. Air looks like empty space. It's invisible, right? So is it made of molecules? What do you think? Okay, well, what I have here are some cans. And these cans have air in them because they're empty. All right? And you can probably see some steam coming out of some of these cans. That's because they're on a burner. They're really hot. Okay? Now, as they're hot, those air molecules are spreading apart, right? They're getting farther and farther apart, and some of them are actually escaping the can as they spread apart. What I want to do is throw these cans into some water. Now, that water is obviously cooler than the cans are, so what do you think is going to happen to the air? It's going to explode? What do we got to do this thing? Okay. So, on the count of 3, and then 2 food, I'm going to dump one of these cans into this water, and you tell me what happens. Ready? 3, 1, 2. It's floating. It's full of air. Okay, so that one didn't work. Let's try another one. Now this one here, I don't know if you can tell or not, this burner here is not as hot as the other one. So, these molecules aren't as hot and they're not escaping as much, right? So let me try another one and we'll see what happens. 3, 2, 1. Okay. So on our cans where the molecules aren't as warm, it didn't do anything, did it? Let's try these here where there's steam escaping. So we know that these are a lot hotter, right? I'm going to turn these off so don't forget. So I do forget. Okay, now on the count of 3, we're going to try it with some really hot air. Some really hot cans. Ready? 3, 2, 1. Alright. Now that one. This can got crushed as soon as it touched the water. Now, if you look at this can, what happened here is that those molecules are really, really hot, right? And they were spreading out, and they were way spaced out because they were so hot. But when I dump it in this cold water, those molecules cool off, and they get close together. And that allows the air around the can to squeeze on it. Okay? So, the air is always squeezing on all of us. It's something called air pressure. Everybody say air pressure. That's the air pushing and squeezing on everything. So when we shrink the molecules inside of here and get them closer together, it allows the air around it to squeeze it. Let's try one more can and see how this one works. Okay, ready? 3, 2, 1. Alright. So this can here. So this can here. You can see it did the same thing, right? It got crushed by the air around it. So, I'm going to, these ones that didn't crush, I'm going to try this experiment with them again. So I'm going to let them stay on here, I'll come back to it in a little bit. Now, let's see here. I'm putting a little bit of water in, that way I know that they're hot enough, alright? So I'm going to put that right here. Now, we talked about molecules. Everybody say molecules. We talked about air pressure. Everybody say air pressure. We talked about the atmosphere, right? The atmosphere is a layer of air around the earth. So there's air all around us. You're breathing it right now. And that air has stuff in it. Okay, that air has dust in it. That air has air and nitrogen and all kinds of other things in it. That air has water in it. That air has all kinds of stuff in it. And the atmosphere is where we get all this cool stuff that happens in the weather to happen. So, how does the atmosphere and air pressure relate to weather? I just burped really quiet. Yes. Do you know? Yes, okay, so air is a key component to how all this stuff affects each other. Check out this highly scientific map that I have here. Now, this map, you guys can't see it, okay. This map here has an H on it. What do you think that H stands for? High, as in high air pressure. Not as in hi, how you doing? It's high air pressure. Now you'll notice that around here, our high air pressure doesn't have much stuff around it, does it? That's because in areas of high air pressure, we don't get lots of clouds and storms and things like that happening. But look over here with our L. What's that L stand for? Low air pressure, absolutely. And our L has lots of stuff going on around us. So air pressure must be related to how this stuff works if it can change from having nothing happening to all kinds of stuff happening. We have fronts and we have clouds and we have storms and everything going on over here by our low air pressure. So, to talk about those things, I do want to try one more thing first with you. Now we crushed these little cans, right? I'm going to have these on here. Oh, yeah.